Hello friends, welcome back to this online lecture series on earthquake resistant design of structure. In the previous lectures we have been discussing regarding the earthquake protective systems which are going to help us enhance the performance of reinforced concrete buildings when subjected to lateral loads. And under the same topic we have discussed last time regarding the base isolation, and today again we are going to talk about one more characteristic feature which, if introduced in the building, is going to increase the life of the building to a good extent, and that is what we are going to discuss today, which is known as dampers, right? So let us start today's discussion where we will be discussing regarding the basics, or very wide, what is the necessity of introducing dampers in the building, what is the function of the damper, how the building behaves, whether when the damper is installed in the building or when it is not installed in the building, right? So first of all, coming to the main point or the basic point, that is what is the necessity of having the earthquake protection system. Now if you remember the philosophy of IS 1893, which is known as the design philosophy, right, in that we have discussed that the code is discussing basically three categories, where the first category is the minor earthquake, second is the moderate earthquake, and third is a strong earthquake. In all the three categories it has been clearly mentioned that the structure is likely to undergo deformation, but the collapse of the structure should not be there. And in case of strong earthquake also, it is mentioned that even if the structure is going to be of damage in the structure is going to be of irreparable nature and it is going to ultimately collapse, but then also it should give enough time for the people to evacuate and the safety of the property. That is, you can say that from all these three guidelines, or all these 3 points that are mentioned by the Indian code, the philosophy behind the earthquake resistant design of structure is to save human lives and avoid the loss of property, right? And that is why it becomes an additional responsibility for the structure engineering who is going to undertake any project in the field, that he has to ensure the safety of the building, he has to ensure the safety of the people, and at the same time the loss of property should also be averted as far as possible, right? So the objective of earthquake resistant design is to design a building which is going to help us resist the ground motion and avoid the collapse of the building in all possible situations. In recent times, many new systems have been developed which will help us, or many new systems have been developed which result in the lesser amount of force that is transferred to the building, or it also results in the dissipation of seismic energy, as a result of which the building will undergo less amount of earthquake shaking, right? Out of these various systems that have been discussed, then the damper is one of the system which is widely researched, implemented and accepted in the field of structure engineering, and that is what we are going to discuss today, that is the dampers, right? So if you look at the classification chart of the earthquake protective system, then basically 3 heads are there. First is the passive protective system, second is the hybrid protective system, and third is the active protective system. Now if you look at the passive protective system, then under the passive protective system the first name comes is the tuned mass damper, which we are all very well aware of. Second is the energy dissipation, and third is the base isolation method, right? If you look at the hybrid system, then in case of hybrid system, three cases are there. First is active isolation, second is semi-active isolation, and last one is semi-active mass damping isolation, that is semi-active mass damping, right? And lastly, if we look at the active systems, then in case of active protective systems we can say that 3 categories are mentioned as active mass damping, then active bracing, and lastly the adaptive controls. Now out of these 9 different categories that we have seen over here, the tuned mass damping is one of the familiar things that we are well aware of, and as a result of that we come to the discussion of dampers, where we are discussing regarding the different types of dampers, the behavior of the building when subjected to lateral loads under the effect of damper, and lastly the function of dampers as well. So if I talk about the dampers itself, then what is the definition of damper? The damper is basically a mechanical system which dissipates the earthquake energy into specialized devices which deformed or yield under the effect of earthquake. So what is going to happen is that the mechanical devices are going to be used as a medium, and these mechanical devices have a special function, and that function is to dissipate the energy. That is, they either convert their earthquake energy into vibration energy, or into heat energy, or mechanical energy, right? So basically dampers are a mechanical system that dissipates the earthquake energy into specialized devices which deform or yield under the effect of earthquake. Right? Now what is going to happen is that when these devices are going to be used, then they will enhance the process of energy dissipation, and as a result of that, lesser amount of force will be transferred to the actual structure, and when lesser amount of force is going to be transferred, then as a result of that, the deformation of the structure is also going to be controlled to a great extent. Right? And lastly, when these seismic waves are transmitted through them, these dampers amount a lot of good amount of energy, and that is why the motion of the structure is also going to be dampened. So the next question comes is, what will be the behavior of building, and what is the difference for a building where that is one building we have where the damper is installed, second building is where the damper is not installed. Then which building is going to perform better? Obviously the answer is going to be the building where the damper is going to be installed. But why that building is going to behave better, that is what we are going to look. Right? So when ground was, as we know that whenever the ground motion is going to be initiated, then as a result of that, after the release of energy, the seismic waves are going to be created. When these seismic waves will be created, they will travel to the Earth's geology and reach the surface of the Earth, and when they will reach the surface of the Earth, they will initiate the ground motion. Right? Now when ground motion will be initiated, then as a result of that, the seismic, wave energy will be transferred to the building, and due to the transfer of the wave energy, there will be motion of the structure in the opposite direction due to the presence of inertia. And as we know that inertia is attributed to the mass of the building. Right? So when the movement of the building will take place in the other direction due to the presence of inertia, then the distortion of the building will start, and this distortion wave will try and travel to reach the top of the building, that is up to the terrace level. Right? So as a result of that, the continuous shaking of the building will start, and due to this continuous shaking of the building, the oscillations in the buildings are likely to be increased, and when these oscillations will be likely to be increased, then as a result of that, the collapse of the building is likely to be initiated. Right? So in order to avoid such a circumstances, the damper shall be used in the building, because due to the presence of the damper, the wave energy or the amount of seismic waves that will be transferred to the surface, transferred to the building will be absorbed to a greater extent, and as a result of that, the motion of the building is going to be controlled. Same thing can be observed here in the figure also, where the figure on the right hand side is indicating the building without the damper, and second is the building with the damper. So in case of building without the damper, you can see that the violent shaking of the building will take place, and as a result of the reversal of stresses due to the earthquake or the lateral forces, the back and forth movement of the building will be there, and due to this back and forth movement, large amount of lateral deformation is likely to take place in the building. Right? However, when the dampers will be present, then in case what is going to happen is that good amount of energy will be absorbed before it is transferred to the building, and when this dissipation of energy will take place, then as a result of that, lesser amount of energy will be transferred to the building, and due to this, the motion of the building will be dampened to a great extent. So as you can see, the amount of deformation that is taking in the building without damper and amount of deformation that is taking place in the building with damper is differing. Right? So in case of the building with dampers, the violent shaking will not be there, only light shaking of the building will be there for a very shorter period of time, and that is how we can say that by use of dampers, the performance or the motion of the building is going to be much better as compared to a building which is not having dampers. Right? Now that brings us to the question of what is the actual function of damper. I think by now the function must be much clear to you, but let us look at it once again. That is, the dampers dissipate the wave energy that will be transferred to the building when the seismic energy will be taking place. Right? And as a result of that, the oscillation of the building will also initiate. Whenever the seismic wave will transfer, then as a result of that, what is going to happen is that the inertia force will try to move the building in the opposite direction, and whenever the movement will be taking place in the opposite direction, due to the distortion wave, the oscillation of the building will start. Right? Now by proper configuration of lateral resisting systems and by selecting the proper location of dampers, what is going to happen is that these devices are going to intercept the earthquake energy that is transferred from the ground, and they will intercept and they will dissipate this energy either from the that is dissipate the energy from the seismic energy to either heat energy or any other form of mechanical energy. And as a result of this dissipation of energy, the amount of forces that will be transferred to the structural elements will be much lesser as compared to the buildings without dampers. And as a result of that, the economy in the building will also be achieved. At the same time, the stability in the building will also be achieved. Right? So due to the earthquake induced mechanical energy in the system, the energy in the system is transformed into thermal energy within these devices. And these devices enhance the damping characteristics of the building, and as a result of that, the amplitude of the structure will be controlled to a greater extent. Right? So this is basically the function of the damper, that they will dissipate the energy in any other mechanical forms, and due to dissipation of the energy, the damping characteristic of the structure will be enhanced. And once the damping characteristic is enhanced, then as a result of that, the motion of the structure is going to be controlled, or it is going to be dampened to a greater extent. Lastly, same thing as we have discussed in case of base isolation, whether again damper is going to be an economic solution or not. So in case of damper also, you can say that the initial investment is going to be on the little bit higher side, but there are advantages also. Why? Because as we have seen that whenever a product is there where the initial investment is high, the maintenance cost is going to be minimum. So same thing applies to the dampers also, where in case of dampers we can safely say that once the damper is installed, then the maintenance is going to be on the minimum side, right? So as a result of that, no maintenance will be required during the life of the structure. Even after the shaking of the earthquake has taken place, then as a result of that, only the position of the bolts and the plates needs to be checked, so that the function of the damper is not changing. And lastly, what is going to happen is that even if there is a shaking which is going to be unprecedented, even in that case, if you want to change any or if you want to make any minor changes in the parts of the damper, that can be also easily done on the side. And once this is done, then as a result of that, the rigidity will be there in the structure, which will be able to resist the earthquake forces or the wind forces to a great extent. And lastly, we look at the different types of dampers. So here I have listed down 7 types of dampers that we are going to discuss, where the first damper is known as the hydraulic damper, second damper is the viscous damper, third is viscoelastic damper, fourth is friction damper, fifth is tune mass damper, sixth one is the yielding damper, and seventh one is the magnetic damper. Right? So these are all 7 different types of dampers. These all the different types have different types of, all these different types of dampers have different materials, and their characteristic is also different in the way in which they dissipate the energy and help the structure in achieving a better performance. We look into the details of these dampers in the next lecture. Hope that today's lecture has given you a clear idea about the definition of damper, the function of damper, and the behavior of building in where the damper is going to be installed. Stay tuned for further lecture series.